we discussed counting to 10 using addition and subtraction of numbers. And in this video, we're going to take it a step further, and we're going to use linear algebra to map the Cambridge diet. So, how to look like this man right here. Let me shrink that a little bit. Try and keep it in your sight. So, how do we start by solving this problem? We probably need some equation to map the ingredients we have to the amounts that the Cambridge diet supplies. And luckily, I have a handy chart available for us. Let me go ahead and copy our chart. And so you might be looking at this, and you might be thinking to yourself, hey, Sal, this looks pretty hard. How do we actually solve this? So let me show you. So we're going to start by letting a variable represent the amount of non-fat milk we have. And so we're going to call this variable x1. Actually, let me change the color on that a little bit. So we're going to have non-fat milk be x1. And so this is a scalar quantity. And it's going to represent the amount of non-fat milk we have. So x1. So this is the amount of non-fat milk we have. And so the next part of our equation is we need the amount of nutrients per unit. So again, unit of x1 or of non-fat milk. And so we can use a vector to represent this. A vector. And so go ahead and pause the video and take a second to think about what that vector would be and come back when you think you have it. Okay, great. So hopefully you thought about it and you saw that in our table we have three main macros. So we have protein, carbohydrates, and fat. So let's go ahead and these are going to be our vector values. Let me go ahead and switch the color real quickly. Okay, great. And so we don't just have, one ingredient. We also have another ingredient, soy flour. So we're going to do the same thing and go ahead and pause the video and think about what variable I'll call this. And you might be thinking, hey, Sal, it seems to be x2 going by our pattern, and you'd be right. And just following the pattern, we're going to put our protein value, which is 51 here. Sorry, I need to change the color there. So we have 51. It seems about right, maybe a little off. And then we have 7. So this is, again, our protein, carbohydrates, and fat represented as a vector. So again, we have a scalar multiplied by a vector quantity. And just for time's sake, I'm just going to use a completely different color. And we're going to use x3 here. And finally, again, x3 represents whey. And we'll go ahead and finish this drawing. Okay, so we have our equation, but an equation needs to be equal to something. So go ahead and pause the video and ponder. What do you think this equation is equal to? Okay, so hopefully you thought about it. Hopefully you paused the video and you realize that we're saying it's equal to the amount in grams supplied by the Cambridge diet per day. Again, the original problem we're solving is how to look like this. And so this is a vector quantity as well. And we're going to have the amount of protein, which is 33 carbs, and fat we need per day. And now that we have our equation, again, so that we have scalars multiplied by vectors to get one final vector here, how do we actually solve this? And this is a little bit of a step up from our counting video last class, but we can actually go ahead and put all of these values into a matrice. So let me go ahead and pick maybe a nice shade of white for our matrice here. I'm just going to go ahead and put all of these values into our matrice. And again, each column represents a column here. So this is the amount of x1 we need is what we're going to be solving for here. So let me go ahead and just put all of these values into our matrice. 13, 74, 1.1, and I might even add a little dash line here. You don't actually need this though. This is just for my pleasure. And you'll get this. Okay, so how do we solve this matrice? Well, we talked about this. We talk about this in a future video that I haven't released yet, but we can go ahead and plug all these values into our calculator, and just to save a little bit of time here, because again, time is the one variable we can't get more of. That's I have my philosophical takes in Sal Khan's philosophy videos, but we'll get a matrice that looks like this. And so from this matrice, we can write that. And I'll go ahead and use a nice shade of red here, or pink here. And we can say that x1, which again is this variable here, is our first pivot, is equal to 0.277. 277. So this is the amount of non-fat milk we need in our diet to look like this. Okay. So now moving on, we're going to go to our next pivot. And we can see that, again, that represents x2. And we can see that x2 is 0.392. And this is, again, as you'd expect, the amount of soy flour we need in our diet to look like this. And finally, go ahead and pause the video if for some reason you don't see the pattern. But x3 will be, which again is our last pivot here, will be represented as 0.233. And so this is how you solve the Cambridge diet using linear algebra.